Hello guys, welcome to our channel that is CodePlayJatin. Okay, and guys, as you know that the CodeChef cookoff is already over. Okay, so today we will be up solving it, and the contest name is cookoff. It's Feb cookoff. Okay guys, so it's Feb cookoff 2022. So guys, here we are at the contest page. Okay, and like we will be solving div 3 category. So the first problem is something with the name of peaceful party. So guys, peaceful party is a problem where there is a mayor. Okay, there is a mayor of city and he is contesting election. Okay, so let's say three constituencies are on which he is focusing: constituency A, B and C, and the people in each of them are, like, voters in each of them are PA, PB and PC, and he knows that there is a conflict of PB with PA and PC. Okay, and he wants to give party to all these people, but he wants to maximize invitations, Okay, and as we know that PB is having that, as we know that PB has conflict with PA and PB. Okay, so it means that he cannot invite PB when there is a person either from PA or PB or from PC. Okay, and vice versa too. So what we can do is, like, to maximize his invitation, what we will do, we will check if PA plus PC is greater than PB. Okay, then we will see out, like, we have to see out number of invitations that he can send. We will see out PA plus PC, else we will see out PB. Okay, so now let's go to its coding part. Okay guys, you can verify these test cases, too. Okay, the output for these is, okay guys, see, like, the output for this case is 6. It means it is PA. Okay, it is n, it is basically number of test cases, it is T, and it is PA, PB and then PCC. When PA is 2, PB is 3 and PC is 4. PA plus PB, it is 6, and 6 is greater than 3, so we are printing 6. And here PA is 1, PB is 5 and PC is 2, and we know that PA plus PC gives us 3, but 3 is less than 5, so we are printing 5. Okay, because you have to print maximum count. And here also, like, 8 plus like PA plus PC becomes 16, and 16 is greater than 8, so we are printing 16. Okay, so in this way now we will be doing its coding part. Okay guys, so now we will first of all declare int of PA, PB and then PC. Then we will input PA, PB and PC. Then we will just print out, see out maximum of PA plus PC and PB, PA plus PC and PB. Okay, so now we will try to run given sample cases. and it shows 6 5 16. Okay, and it's same as the sample output cases. Okay, so now we will try to submit our problem. And you guys, like, the status is correct answer. Okay, so now we will be heading over to second problem. And second problem is something like lazy salesman. So now the problem is lazy salesman. Okay, and like, I expect that you have read this question. Okay, so now we will be going to its conceptual part. Second is lazy salesman. Okay guys, like, it's about a salesman whose name is Ved, or Ved, whatever you call. Okay, his goal is to just earn money. Okay, his goal is to earn money and sleep. Okay, or you can say have rest. Earn money and rest by taking holiday. Okay, and he needs W rupees in n days. He needs W rupees in n days. Okay, to sustain himself with his expenses. Okay, so, and we know that like, the system is giving us his income on each day. Okay, in form of AI. Okay, for n days. What we have to do is, okay, like I will try to explain this problem with the help of sample cases. Okay, 2 3 4. Okay, no, it's not this correct. Yeah, it's fine now. Okay, here, like, it is the number of test cases. In input we are getting NW and AI, like array. Okay, where n is the number of days in which he has to earn money, W is the amount of money, that is the minimum amount of money he requires to sustain himself. Okay, and 3 to and then 3 to 6 1 is his salary on ith day, or you can say his income on ith day, or you can say that AI. Okay, and n for this case is 5 and it is 10. Okay, so, like, the concept is, on first day he is earning 3 rupees. Okay, he is earning 3 rupees while he needs 10 rupees, total of 10 rupees to sustain himself in 5 days. Okay, so he first, let's say money, initially he had 0 money. Okay, in the first day he earned 3 rupees. Okay, now on the second day he earns 2 rupees. Now he has 3 plus 2, total of 5 rupees. And then he earns 6 rupees more. Now he has a total of 11 rupees. Okay, 11 rupees. As he is very lazy person, as he is very lazy person, so as soon as he find out that the money that he has is equals to or greater than W, okay, he will leave the work and he will go to holiday. He will take holiday. Okay, so we have to print. Okay, 3 to 6. For each test output, the maximum number of holidays that Ved can take. We have to print number of days that Ved can take. Okay, we have to print number of days, number of holiday, number of maximum holiday. Okay, so we know that in 3 days he earns sufficient money, while a total of 5 days is given to him. So he will take rest for 5 minus 3, that is 2 days. Okay, he will take holiday for 2 days, and we have to print this maximum count. So the logic here will be, how we can do, see they are given in random order. So see, they are given in random order. Okay, so our logic will be, we will first reverse sort it, like we will sort them it in a decreasing manner. So let's say we sorted it in 6 3 3 2 1. Why we sorted in the reverse manner? Because on the very first day he earns a maximum sum of money. Okay, like here the money becomes 6, money becomes 6. Now 6 plus 3 it becomes 9, and now it becomes 12. And he find out that as soon as he finds, like, because he's a lazy person, so he wants to earn maximum money as soon as possible so that he can get a holiday. Okay, so we reverse sort it. Okay, and now here, as he finds that 12 becomes greater equal than w, he will leave the job and he will see out n, he will see out my n minus discount. Okay, like he is earning this much rupee in 3 days, so he will see out n minus 3, and n here is 5, so he will see out 2. Okay, like you can try to understand this question in a better way in your, while trying with a given sample case on your own. Okay, it will help you to understand the concept better. So now we will go into its coding part. Okay, see, like this is also a very good case, it is also very good test case is given. Okay, you should try to write and explain, write and understand it on your own. Okay, so now we will be going to its coding part. So guys, now we will be looking at the third question. Okay, and third question is prefix permutation. Third question is prefix permutation, and it is a, like, seriously very good question. Okay, like first of all, it consists of two parts: permutation and prefix. Okay, like what I felt was its language to understand was a sort of a little bit of tricky. Okay, like once you have understood what the question is saying and what is demanding, the coding part is comparatively very easy. Okay, so guys, in this question, an array A of length k is given to us. Okay, and we have to construct an array of n length, okay, something with the prefix permutation. Okay, so first of all guys, like what is permutation? So let's say that permutation of size n is such that first of all it contains all the numbers, all numbers from 1 to n. Okay, and 1 and n are included. Okay, from 1 to n, and all numbers are unique numbers. Okay, it means that permutations is just basically all unique numbers from 1 to n. Okay, permutation of size n just means that all unique numbers from 1 to n. Okay, and let's say when n equals to 5, 7 or anything, okay, it means that permutation will be 1 2 3 4 5 2 3 4 5 1, like anything, 5 4 2 1 3. You can arrange these 5 numbers in 5 factorial ways. Okay, in 5 factorial ways. So there can be a total of, like, let's say 5 factorial permutation of size 5. Okay, so like anything. In the same way, there can be permutation of size 7 factorial, a total of 7 factorial. Okay, non-repeating in this permutation. Okay, so now prefix. Now what does the word prefix means? Prefix is something like, as we have learned in English, prefix that comes first. Okay, like if we are talking about this position, then all these mentioned, like then the thing mentioned before him is prefix for him, for position. Okay, prefix. And or Hindi you can say that come first or pehle. Okay, so now uh, now let's say an array of size 4 was given to us, and that was, I think, 3 6 7 8. 3 6 7 8. Okay, so let's say we had an array of size 4 and the numbers were 3 6 7 8. We were required to print an array of size n. Okay, and n was 8, such that it had prefix, such that it had permutation, that such that it has permutations, such that it has permutations at index equals to ai. Okay, or we can say that at index equals to ai is 3 and then 6 and then 7 and then 8. These are it is a1, it is a2, it is a3, and it is a4. Or we can simply say that we have to make an array size 1 2 3 4 5 6 7 and then 8. Here is, let's consider it as 1 2 3 4 5. Okay, and although like 1 2 3 4 6 7 8. Okay, so at this position, then at this position, and at this position, we should have an, okay, it will eraser. Okay, like at this position we should have permutation, and then at this position also, like 6 going from there, and then 6 to 7, and then 6 to 7. Okay, now where it is, let's if I try to draw it clearly. One, two, three, 4, 5, 6, and then 7. Okay, okay, so let's say it's ai equals to 3, ai equals to 6, ai equals to 7, ai equals to 8. We want to make a array such that it contains a permutation at this position, at this, and we chose this, so, and at this position. Okay, so now permutation at position 3 will be that that from here to here it contain all the unique numbers. Okay, like we can have 1 2 3. Okay, or we can have 3 to 1 also. Let's go with that case, it will help us in other cases, understanding other case too. Okay, like let's say we can fill 3 to 1. It means that at I equals to 3, I mean till I equals to 3, is it lagging? So it means that at I equals to 3, starting from 1 to 3, it should contain all the numbers starting from 1 to 3. It means it should contain 1 to 3, and the number should be unique. Okay, like 3 to 1 are unique. Okay, now at I equals to 6, okay, and I equals to 6, it should have all the numbers from 1 to 6. So now we have, see, we have already entered number from 1 to 3. Now we have to enter number from 4 to 6. Okay, 4 to 6. So now we can enter 4, 5 and 6 in this way. 4, 5 and 6. Okay, now at I equals to, till I equals to 7, it should have all the numbers from 1 to 7. Now we have already 1 to 6. Okay, so now we need 7 here, and at I equals to 8, till I equals to 8 we should have all the numbers from 1 to 8. Now 1 to 8, so it is a permutation. See, it is a permutation. It is a permutation. It is satisfying P3 also, it is satisfying P6 also, it is satisfying P7 also, and it is satisfying P8 also. Okay, now it is a simple permutation. Okay, but the question demands us one more step. Like the question says that, so now going to question third. Okay, well, there is a thing that says that find any permutation P of length n such that only the prefixes of length AI forms a permutation. Okay, it means that only the value, only AI. Okay, it means that only AI should form permutation. Okay, but see here 4 is not AI, because AI is 3, 6, 7, 8, but here 4 is also forming permutation. Like till 4 we have all the numbers from 1, 2, 3, 4. Till 5 we have all the numbers from 1, 2, 3, 4, 5. Okay, but here at I equals to 2 we are not getting permutation, because we are missing 1 here. Instead of 3 we should have 1. Okay, so like in this way we cannot arrange them directly, we need to insert them in reverse order. Now see what happens if we insert them in reverse order. If we insert them in reverse order, then numbers would be like 3 to 1, and then 6, 5, 4. Now we can see that at I equals to 6 we are getting 4, but from 1 I equals to 1 to 6 we are getting all the numbers from 1 to 6. Okay, so it is satisfying the condition that we should have a permutation at I equals to 6, and it is also satisfying the condition that it should have permutation at only AI. Okay, because now at I equals to 4 we do not have permutation, at I equals to 5 we do not have permutation. Okay, so now I hope the question and the concept is almost 50 to 60% clear to you. Okay, I know it's a little bit tricky, so now we will try to understand this question further with the help of another test cases. Okay, so now let's take this case now. Okay, here n equals to 7, here n equals to 7 and k is 1. Okay, it means that an array of length k is given to us, and so AI equals to so a1 equals to 1. Okay, and we have to print, okay, a1 is 7, a1 is 7, and we have to print an array and another array of length 7, where n equals to 7, such that it contains prefix permutation. Okay, we have understood the meaning of prefix, like just it means that just the values coming before prefix, before the indices. Okay, and we have seen the meaning of permutation also, like it should have all the unique numbers ranging from 1 to that AI. Okay, so initially we have only one element in array, that is 7, so a1 equals to 7. Okay, and we have to construct another array of 7 size. So let's say 1, 2, 3, 4, 5, 6, and then 7, in such a way that it has permutation at only a of I, and a of I is 7. It means that it in such a way that it has permutation at only this 7th position, at this position. Okay, now we have seen that if we insert the numbers directly in a random order or in ascending order. Okay, let's say let's make a case. Let's make a case. First we insert them in ascending order. Okay, so then the number would be like 1 2 3 4 5 6 and then 7. I think I have made one extra. 1 2 3 4 5 6 7. Okay, yes, yes. Like it should have a permutation at this position. Okay, see, now if we insert them directly, then it is having permutation at this position also, this also, this, like at all the position it is having permutation. So why it fails? It fails because it has permutation at all the position. I belongs to 1 to n. It has permutation at all the positions, at all position. Okay, but we want permutation at only a of I position. Now what if we insert them in descending order? Okay, descending order, then the number will be like 7 6 5 4 3 2 1. Now we can see that here I equals to 1. For making it a permutation, it should have all the numbers ranging from 1 to 1, but it is 7, so no. Now it's I equals to 2. Again, for making a permutation at this position, it should have all the numbers ranging from 1 to 2, but we do not have. Again, like skipping this position. Okay, checking at this position, here I equals to 5. Now to make a permutation at this position, it should have all the numbers ranging from 1 to 5, but it does not have. So in this way, now at this position I equals to 7, it should have all the numbers ranging from 1 to 7. Okay, and see, the thing is that it has like 7 6 5 4 3 2 1. Up to this position we are getting all the numbers ranging from 1 to 7. Okay, so it is a permutation. So it is permutation. I hope you understand this question now. Okay, and like here we have seen that we have to check, like when we have to, wait, it's ready, here it is. Like we have seen that when we have to insert, like when we have to make permutation at multiple position, we have to check we have to care for the values that we have already inserted. Okay, that we have already inserted. So now let's head over to its coding part. Okay guys, I hope that now you have understood the concept. Like what you can do is, if still you are doubtful, okay, what you can do is try to understand through the code. Okay, if still you find yourself uncomfortable, then go through the conceptual part again. Okay, and then go through the code. Then I'm damn sure, okay, then you will understand the concept for sure. Now first of all we need to input n and k. Okay, and like we need two vectors. First is that is given to us, of size k. Okay, then you will take in for these values. Say in given of I. Then you will need another vector to print out our final answer of size n. Mind it will be of size n. Okay, then we will need two loops here. Okay, we will need two loops here. First of all, first loop will iterate over all the indices, like first will iterate over all the values of the given vector. Okay, and second loop will, like, we need this loop for inserting values in the an array vector. Okay, while it will be initialized from let's say our given, it will be initialized from our given indices, like from the values that is given to us. Okay, so it will be initialized from a given of 0, like given of 0, it will be every time 3. We will update I with the 3. Okay, and then given j equals to 0, then it will be 3 to 1, 3 to 1, 3 to 1. Okay, we will initialize with the given of I. Okay, and j will be like we will check what will be the j maximum limit, j minus. Okay, and we need to just insert the value of j. We have seen that 3 to 1 it was getting decremented, so we were basically inserting those values in the answer. So we need to insert answer dot pushback j. Okay, and let's see, here we have seen that in this. Okay, let me draw it again. Here we have seen that in this we have to make an answer vector where we have to insert 8 values. Okay, let I equals to 1 2 3 4 5 6 7 and 8. Here we have to make permutation at this position, at this position. At this position, and see, like we have seen that we have inserted 3 to 1 here and then 6 here. Then after inserting here, again we are updating rj with the error of 1. Okay, like with the given of 1 here, given of 1. After coming here, we were inserting 7, so we were updating j with the given of 2. But we were also keeping a counter on what values we have inserted. Okay, so that we do not repeat them again. So for this we will declare a variable called int of previous, and we initialize it with a 0. After every inner loop, we will update it with the error of 0 with the given of I, so that we can have a counter that okay, we have checked for given, we have done our function, we have performed our operation for first indices, that is 3. Okay, so now we need to clear for the second one, that's why. So previous given equals to I, so it will be here, yeah, and then j will never reach its previous value. Okay, because we have to insert unique number, so j will never reach, that's why j is greater than, okay, given I. Okay, and then now in last, finally we will output our answer. Okay, so cout I. So now let's try to run this code. Uh, 32000000. Okay, here like we won't declare it with the size, else it will insert 0, it will initialize with them 0. Okay, and it should match with our output 3216547876. Like we can see the output is matching 32164 to 31646478. Okay, like we have done another operation. Okay, but it's correct, and now we'll try to submit the problem. So guys, I hope that now question is clear to you along with the code. Okay, if still if you have problems, so I would suggest to go through the solution again. Okay, because it's a little bit tricky question and we should accept this fact. In the meantime, we can open for and it shows answer correct. Okay, okay, it shows that perfect permutation. Again, it's a permutation related question. Okay, but it's an easy one. Okay, exactly, given 2 integers and you need to construct a permutation p, exactly k integers permutation. Okay, so guys, let's head over, like you can read the problem on your own. Okay, so let's head over to its conceptual part. So we need to insert a page. Its title is perfect permutation. Okay, so here like two numbers are given to us, n and k. Okay, and we have to construct a vector or anything. Okay, such that only k numbers are divisible, such that only k numbers are good. Okay, like term that they are using is exactly k indices that in that permutation are good. Okay, so let's say uh, n is, let's copy their test cases. So they have given n as 1 and k as 1. Okay, and then 6 and 2. First of all, how we can determine whether a number is good or not? Okay, how we can determine whether a number is good or not? So they have given that if ai modulo I equals to 0, it means that if ai is divisible by I, then it is good. And permutation, again, all the numbers ranging from 1 to n. Okay, and unique numbers. It means that, let's say that we have a permutation with a like 1 2 3 4 5 6 and 7, taking its I value as I equals to 1 2 3 4 5 6 7. What we can see here is ai is 1 and I is 1, and we can see that 1 modulo 1 equals to 0. Okay, so one number is divisible, so we have such one good number. Then 2 is modulo 2. Okay, we have 2 such number. 3 modulo 3. Okay, 0, we have 3. In this way we can see that these all are divisible. These all ai, we can see that all ai modulo I equals to 0. So in this sequence we have such 7 good numbers. Okay, so but the question is, it states that we should have only k good numbers, like perfect, we should have only k perfect good numbers. Okay, so now consider that case when n equals to 6 and k, consider n equals to 6 and 2. What we can do is, let's say if we make a general sequence, that is 1 2 3 4 5 6. Here, out of these 6 number, all 6 are divisible. Okay, all 6 are good. So but we need only k equals to 2 divisible, that is k equals to 2. We need only 2 good. Okay, so we cannot make it. Okay, it voids our requirement. So what we can do is, let's try it in reverse order. So 6 5 4 3 2 1. Again, I like here I will be 1 2 3 4 5 and 6. What we can see is, like, it is divisible. Okay, and yeah, only this is divisible. So here we are getting only one good number, but we want 2 good numbers. Okay, so it also voids our requirement. So in this way, like, the concept is this thing. Okay, like the question demands us in this way. So now how we can do this question? Okay, so now let's consider cases. Case first. When n minus k equals to 1, it means that we can have n minus 1 such good numbers, n minus 1. Okay, we will see what's the benefit of separating this case. Let's say what we can consider is, let's say n equals to 5 and k equals to 4. Okay, let's consider that n equals to 7 and k equals to 6. Let's go with the general case first. Like, what if we arrange them in this normal way? 1 2 3 4 5 6 7. So here we will have 7 good numbers, but we need 6. Okay, but we need 6. It means we need to do some manipulation. So what we can do is, let's say we also know that whatever the value may be at this I equals to 1, it will always be divisible. Okay, so what we will do is, we will insert, let's say, n here. So it will be 7 2 3 4 5 6 and then 1 here. Now what we are seeing is that they were already divisible. It is always divisible. Okay, but it is not divisible because here I is 7 and 1 modulo 7 is not equals to 0. Okay, so in this way we can deal with this special case, okay. So here we have one such number, 2 3 4 5 6. So in this way we are getting 6 good numbers and it satisfies our condition. Okay, so now I hope you can see that what's the benefit of separating this case. Okay, now let's see when okay, now let's see when n equals to k. Now let's see when n equals to k. When n equals to k, we can check, we can see that we can just simply write the numbers in their usual ascending order, 3 4 5 6 7. Okay, let's consider that n is 7 and k is equals to 7, or you can consider anything like n9 and k9, anything, because they're equal. So in this way they are always divisible by the respective I values. Okay, so it is also a easy case now. Okay, we just have to insert we just have to push back I, and we will start I from 1 to n. Okay, so now when n is not equals to k, like the remaining case, like if it is if you put it in if and it in else if, then it becomes else, okay. So now what we can do is, like we already know how we can make k divisible. We already know that how we can make k divisible. The thing is that we will just insert the values from 1 to k in this normal general order, okay. Let's consider let's try to understand it with the help of example. Okay, let's say n equals to 9 and k equals to 5. Okay, so again the normal numbers that we can have is 1 2 3 4 5 6 7 8 9. So in this way, like we will insert first 5 numbers in this usual way. Okay, so like it will be 1 2 3 4 5. Now we also know that these numbers are divisible by the respective i's, by the I. So now what if we shift them? Okay, now what if we shift them to some other position? Because we know that they are divisible by this, so they won't be divisible by the next value among them, or I mean their next position. Okay, so what we will do is, instead of here we will shift them. Okay, like earlier it was 1 2 3 4 5 6 7 8 9. Okay, now after this k value, that is k, if k equals to 5, after this k value we have shifted them by one position, and it becomes 6 7 8. Now this is empty. Now if we write 9 here, then it will be empty, so we will insert 9 here. Okay, and now we can see that here I equals to 1 2 3 4 5, I equals to 6, I equals to 7 and 8. These are not divisible, but these are perfectly divisible. So in this way we are getting 5 good numbers. Okay, so this is the approach. Like again I'm trying to summarize this. First of all we understood what is the meaning of perfect permutation. Okay, permutation is basically all the unique numbers ranging from 1 to n, and then we saw how they are determining whether number is good or not. Okay, like how they determining if ai modulo I equals to 0, then the number is said to be good. Okay, and they want exactly k good numbers. That's why the question title is perfect permutation. Okay, so now like we try to understand what is good numbers with the help of these cases. Okay, then we divided, then to make our solution easier, we divided them in the case. Like if n minus k equals to 1, then we saw its benefit. Okay, we already we also saw a very important point. Here. Where is the cursor, bro? Yeah, that this position, where it is. Okay, we also saw a point that this is also that the value at this position is always divisible. Okay, and like these are the normal, we have inserted this number at the normal position, so they are also divisible. We just change its value from default value. Okay, so we got k minus 1, so we got n minus 1 and value of k is n minus 1, good numbers. Okay, then we saw if n equals to k, then it is very easy. Okay, we cannot have an easy case than this because we have to insert value normally. Then we saw the remaining part. In the remaining part, we first inserted k values normally so that we know that there will always be divisible. Then to differentiate them from their usual position, we shifted them. Okay, like we shifted these values one position by right, and the gap that we got, we filled it with the n value, with the n. Okay, so I hope the question is clear. Now again I'm trying to explain this last part with the help of another test case. Let's say that n equals to let's say n equals to 7 and k equals to 3. So what we did, we generally inserted first three values. Okay, then instead of directly printing like directly inserting 4 5 5 at their in a normal position, we shifted their position. So instead of I equals to 4, we inserted 4 at I equals to 5, 5 equals to at I equals to 4 5 6, at I equals to 5, I equals to 6, I equals to 7, 1 2 3, and the gap that we got, we filled it with n value. Okay, so in this way we got these as perfectly good numbers and these are not good numbers. Okay, so now let's try to code this question. So guys, first of all we will take input for n and k values. Okay, so now like we divided them in a case. The first case that we saw was if n minus k equals to 1. If n minus k equals to 1, if it is so, okay, so then we will declare a vector also here, vector into, let's say, answer. Okay, with a size of n plus 1. Okay, if n minus k equals to 1, okay, we just if n minus k equals to 1, we just need to do this thing. So what we will do is, for int of I equals to, first of all we will make at first position we will insert our n. Okay, then I will go from 2, then I will go from 2 to n minus 1 position, and we will basically make v of I as I. Then at last it means that at v of n we need to insert 1. Okay, so we have handled this case. See how it becomes once you understand the concept. Okay, else if n is equals to k, we will not have an easy case than this. So for int of I equals to 1, I less than equals to n, I plus plus, v of I will have just like v of I will have I. Okay, then else in the remaining part, first we will insert all the k good numbers. Okay, I will go till k, I plus plus, vi will take the value of I itself. Then what we will do is int of, okay, then we need to fill the gap because we were creating a gap. Okay, like first of all let's shift the position. Then I will start from k plus 1 here, int of I, k will start from k plus 2 here. Okay, k plus 2 here, then I will go till n, I plus plus. Okay, and v of I will be initialized by let's see, if it starts from k plus 1, then it will be like 1 2 3. If k is 3, then we need to k4, then we need to insert it from k plus 2 because we need to insert it at position 5, and at position 5 we want to insert 4. Okay, so it will be initialized with v of I equals to I minus 1. Okay, and see we have created a gap. Like what it does is after this 1 2 3, it creates a gap first of all for I equals to 4 because k equals to 3 and we are starting it with the k equals to k plus 2. So I starts from k plus 2, that I start from k equals to 5, and here like here I is going till 3. Okay, so I start from at position 5, it inserts I minus 1, that is it inserts 4, 5, 6. Okay, and let's say if n is 7, then we need to fill this gap. Okay, so then v of k plus 1 will be filled by n. Okay, I hope it will work. Okay, and in last, okay, and in last, for we will print out our answer for int of I equals to 1, I less than equals to n, I plus plus, it will see out v of I. Okay, so now let's try to run this code. Int of 1 equals to k plus 1 n less than n minus 1, then it shows us that v of I was not declared. Okay, we have declared a vector with the answer and we are using v. Okay, so v and then v int of nk submission queued successfully executed. It's showing us that 1 2 6 3 4 5 1 2 3 6 4 5 6 3 1 2 3. So yes guys, like we can see when 6 2, okay, when 6 2 and it is giving 1 2, like exactly two numbers are divisible. Okay, and like these rest all are not divisible. 6 3 4 5 6 3 4 5 here 6 6 is also divisible. Okay, so we need to look for that. 6 3 3 3 6 4 5. Okay, so there is some error in this code, like it is not giving us correct output, because in 1 to 6 6 is divisible by I equals to 3. Okay, so we need to rectify this error. And like what mistake we are doing here is n. So guys, instead of this, like what we can do is we can initialize I equals to k plus 1, and then you can push back, like we can initialize with I equals to k. And then talking about the gap, okay, like we can insert at v of k, like at n. Okay, we have eliminated the gap. At in the last we can insert k plus 1. So what it will do, it will first like consider case when n is 6 and k equals to 3. First it will insert just normally 1 2 3. Okay, then at position, then here I will start from k plus 1, so I equals to I start from 4. Okay, I start from 4 and it will go till n minus 1. It will go till n minus 1. Okay, I will start from 4 and it will go till 5. So what it will do, at position equals to 4, at I equals to k plus 1, that is at I equals to k plus, that is 4, it will insert 5. It will insert 5, then it will insert 6, and then in the last at v of n, it is at v of 6, it will insert k plus 1, and k is 3, so it will insert 4. So guys, like in this way we have eliminated the gap, because what we saw that in that approach you are getting 1 to 6 and 6 is divisible by 3. Okay, so it will work now. Okay, so now we are running this code. Like it gives us 1 2 4 6 3. Okay, yes, we have handled that case. Okay, so now we are trying to submit this problem, submission queued. So guys, like I wanna say that if you are finding this content useful, so please do like, share, subscribe our content. Okay guys, do subscribe to our channel. Okay, like I'm regularly trying to upload content. Okay, like I'm getting views guys, but like people are not subscribing. Okay, and I need a reason to show, like I need a reason to do this stuff. Okay, I'm enjoying this. Okay guys, but I need motivation. I need more motivation to like being regular in posting content. Okay guys, again, like if you're finding this content useful, okay, so do like, share, subscribe our channel guys. So that's it for session. Thank you very much guys. Thank you.